and then the removal is always order of 1 in both the cases. So we will see this how we can improvise this order of n to log n while we are discussing these two approaches in the queue session. Sorry, tree session. But for you to understand now, remember this: the priority queue acts completely on the priority of the element. So in addition to the data, there will be one more property called priority. Sometimes data itself is considered as priority. So the higher the number, the greater the priority. So in that case, we see. But technically, they should be another attribute known as priority, and depending on priority, we should do the insertion operation. So removal is there is no change, because the element which is in the front will be removed always. But the insertion is little different here. Insertion will happen according to the priority. Okay, clear everyone? So there is one more use case of this thing. If you see, a priority queue will always have elements in sorted order according to the priority. So if the number itself is considered as priority, so it will be a sorted array or sorted list of numbers. But one more point to remember, that insertion is order of 1. So if you are inserting n elements, so it will be n into n. So you don't think of sorting a data set with using priority queues. No, it will be having a time complexity of order of n. If you are implementing using linked list, so if you are implementing using heap, so it will be order of n log n. Okay, so this we have seen DQ, double-ended queue, and priority queue also we have talked about. So all of them are having their own applications, guys. Priority queue, as you know, can be implemented in many features like booking counter. Let's say you are a premium customer to an online booking site, so you will be given some privileges with respect to the normal customer. So in that case, we can implement a priority queue, because according to the priority, if there are 100 people trying to book and all the 100 are normal subscribers, but if I'm trying to book where I have some higher priority, let's say I am a premium subscriber, so I will be given more chance. So in that case, you can use priority queues, and many other applications would be there. Just make a note of these variations, and we'll go ahead. Okay, so let's see. So I will not do the implementation. You can try it out. So it will be inserted head and inserted rear, deleted head, deleted rear, something like that. It's a very simple insertion and deletion. So you can try it on your own, and print will be the same method only. There will no change. So let's see how Java is implementing queues. So that we will see now. Collection APIs in Java has queues. So where is my queue? See, it is having priority queue that I will open, and it is having normal queue. So this normal queue is an interface in Java. So we will see what are the methods that they have. So we have add, we have remove, we have this thing, add, remove, and examine is nothing but the one that will remove the top of the queue, or nothing but the front of the queue. Okay, so there are two variations of insertion and deletion. So one that will throw you exception, like the one that we have created. So where is it? we have created a queue something like this, right? So where we will throw some error. So we can do this thing, or we can just return something like -1, right? So we can just return -1, or we can return null. So there are two ways that we can implement this functionality. So even Java is providing those two ways. So what are they? The first thing is that throws exception, and the second thing is that returns a special value that is null. So these are the methods. So add will add to the front of the list, remove will add, add will add to the back of the for a rear end, remove will remove from the front end, and element will give us an element. So if you want to learn more, you can just go through it. So see this, and insert the element into the queue if it is possible without violating the capacity. So there is also capacity restrictions in Java, because this is a queue, this is a interface. So the class that will be implementing queue is the one that we should see, actually, that we'll also see, returning true or one, all this stuff. Okay, so these are the methods if you see. So add, remove, and queue. So you might ask, like, where is the DQ operation? So where can I have my inserted end and inserted rear? So this will happen at DQ. So DQ is another sub interfaces if you see. So now let's see what are these DQs thing. So see, add first, remove first, get first. Okay, then add last, remove last, get last. So see this head and tail. So in here they are considering head as the back of the list, head as the back of the queue, and tail as the front of the queue. So as I said, these terminologies are never a problem once you understand the concept. So if you see, they are inserting at two different ends, so inserting here and removing from here. So that's something that you should remember. So see this, add first, remove first, and all this stuff. So all you have to understand is how this is again an interface. So what are the things that are implementing it? So if you see linked list is implementing it, that means if you want to create a queue in Java, we have to create an object of linked list. We cannot create an object of DQ because DQ is an interface. So let's see. So linked list being a class, it implements queue, it implements DQ, and it implements list as well. So if you just understand, or if you carefully learn this linked list, you will learn these three data structures together. So that's a beauty of interfaces, I would say, in Java. So one class can implement many interface, and they can achieve the just go through this documentation, you'll understand how they are doing it. So there is one more, like, it is also given how queue works. So it is a FIFO, first in first order, and remove at the beginning, and all those stuff. Okay, so Java is having a very informative documentation. So you can go through the documentation and learn many things about Java's inbuilt things. So not only collection APIs, how hash map works, and how, so there are a few important concepts in Java that you should know, like hash maps, this collection APIs and all. So for that, I will suggest you go through this documentation only. Okay, let's see priority queue. Priority queue is a class. So it implements queue. That means it will have insert and remove methods. So add and all those stuff. So where is my insert? Insert a specific element into this priority queue. So this will be according to the priority. Okay, just learn more about it. So let's go through this definition to understand how priority queue is implementation in Java. Okay, so this is all about Java's priority queue. Just go through this documentation and you can learn many more things about it. I will suggest each and every one of you who are learning Java to at least learn collection API, because that is very important when in respect to the interview. So not only object-oriented Java, concept of Java is important, but collection API is also important. So can we move ahead, guys? Let me know. Okay, so let's see. Now let's try to solve few problems. So we have seen introduction, implementation, variations, priority queue, and normal queue. Then Java has inbuilt queue methods. Okay, now let's try to solve few problems. So maximum in a sliding window. This is a category of problem in arrays, and it's very important with respect to queues. So I'll explain you the problem statement first. So you will be given an integer array. Let's say 3 minus 1, 2, 4, 0, 1, 5, 6, 7. Okay, let's say this is the array given to you, and there will be another integer known as k is equal to 3. Let's say when k is equal to 3 means the window size is 3. So what is a window? Window is nothing but a set of continuous elements. So this is one window. Okay, then this is one window. And just think of it as a let's say something like this. Okay, this is a window. Now if I shift this window to one element, my window will be here. Okay, similarly when I shift, my window will be here. So like that. Okay, so these are the windows, specific windows, and windows are nothing but continuous subarrays. This is still 4, this is still 4, then from 2 to 0, then 4 to 1, 0 to 5, 3 right here. So these are the 3. So last 5 to 6 is the one window. Okay, so now so these are the windows, right? So you are given integer array and you are given a window size. Now you have to print out all the maximum numbers. So if you see, this is the maximum in sliding window, all the maximum numbers of that particular window. So here the maximum is what, 3. So second window maximum is what, 4. Third window also maximum is 4. Fifth window maximum is 4 again. Then here it is 0, 1, 5, it will be 5. Then 1, 5, 6, it will be 6, and then it will be 7. So this should be the output. Okay, so the maximum of each window. So this is the maximum of this thing, this is the maximum of this thing, maximum, 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 and then maximum. Okay, so this is the question. So everyone good with the question? Okay, so now you have to solve this. Now you tell me how will you solve it. So what will be your approach? So think of it for, let's say, 5 minutes, and then we will discuss the solution. Start thinking of brute force approach, then you try to improvise it. Um, will you use stacks? Will you use queue? If you're using, so we are discussing maximum, so will you use priority queues? So think of all the approaches that you can and put them in the chat. Come on, guys, think. It is you that you should be thinking and trying to solve a problem. So I'll definitely explain the solution, but you should give it a try as well. So I will wait today for 2-3 minutes for you to think, and then we will see. Didn't get the question? So everyone told yes, yes, yes. So you are given an integer array and you are given this integer number k, where k denotes the window size. So if these are the inputs given to you, integer array and window size, you have to print out all the maximum elements in each window. Okay, in each sliding window. So the first window is this thing, first 3 elements, 3, 1, 2, maximum is 3. Then the second window is this thing, 1, 4, 1, minus 1, 2, and 4. So then the maximum is 4. Similarly, you have to keep shifting the window till you reach the last this thing, last 3 digits. Then the maximum is 7. So you have to print maximum in each sliding window. Try to think, guys. Come on, guys. There is no answers in the chat yet. Okay, so received questions, received a solution. That's interesting, but it's not possible. So I'll speak out what is the solution. So we will insert all elements in the queue. Okay, find maximum in first k elements, dequeue the first element, then find max in the remaining elements. But the point here is how will you traverse a queue? So a queue traversal is not possible. You have to either insert and delete. So even similar to stack, we have to either push or pop. We have no access to the below elements. So we cannot just traverse a queue, something like we traverse an array or something like we traverse a linked list. So we cannot do that. Okay, so another solution is that we will have two loops, one till n minus k and the till k with max count. Yeah, it's a brute force approach and it should work. Yes. Come on, guys, rest of you think what happened. So I've received only 3 answers out of 158 students. So not even 0.1%. At least think of a brute force approach. So it's very simple, guys. Brute force approach, you can just use 2 for loops and do it. So let's give a solution. We will have something like this, public void. For now, I'm just saying that I have to print. Okay, so the actual question is return the list in Java or return the array. That will be the actual questions in the sites. But for now, for simplicity purpose, I'm just saying that I will just print the values. So here I will have an integer array, and here I will have the k size. So first thing that I can do is if my k is more than arr dot length, then I'll just return. Okay, because my window will not be one. So even in this case, the worst case could be to find the maximum and then return it. But for now, I'm just returning it. So now I can just say that int I is equal to 0, I less than arr dot length minus k plus plus. So this outer loop should go till this point. So till this point. So what is it? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the length and 3 is the thing. So 6. So now if you see 0, 1, 2, 3, 4, 5, 6. So it will go less than 6. So it will be stopping here. So I want less than or equal to. Mm, okay, let's give it like this. Now for int uh, I is for int j is equal to 0, j less than k, j plus plus. Okay, I will have maintain a int min maximum we are talking, right? So max is equal to arr of I, let's say. So I can just say 1. Okay, so here 0 is also fine. If error of I, if error of j is greater than, so what I have to do, I have to check with the maximum value. So I plus j. So every time I am incrementing the I value. So I plus j is less than, or if it is greater than the maximum value, then I have to update the max. Okay, and every time once I do it, I have to print out the value. System.out.println. Okay, so this will try to do it. So it will go n time. It will, so this inner loop will run k times, and this will run n minus k times. So the only point here is, will this thing work? So length minus 1, let's consider this only. What is the length here? 7, 8. 8 minus 3 is 9. 9 minus 3 is 6. So if I give less than 6, it will stop at 5. But I want to stop at 6. Less than or equal to k. So if k is 0, then it will be the problem. So if k is equal to 0, then return. K is equal to 1 means it will be 9 minus 1, 8. Till this point we have to run. That will be a problem. I think it should be less than equal to only. Okay. Let's run this thing now. I am deleting few stuff from here. Int arr. Okay, so I have taken the input, then I have to take the k. Okay, so for now I'm just printing it. And then I will say simply max sliding window, take my array, take my k. Okay, so let's see this. No such element. Okay, k we didn't give, so 3 is k. Okay, so if you see, this is the first window, 1, 2, 3. What is the maximum? 3. Okay, that's for 3. So 1, 2, 3, the maximum is 3. Then 2, 3, 4, the maximum is 4. But here 3, 4, 5, the maximum is 5. 5 is missed, so we have to give it less than or equal to. Okay, 3, 4, 5. But if I give 1, so 1, 2, 3, 4, 5. Okay, so if 0, that means the window size is 0. So nothing will be printed. So if I give 2, window size is 2. So 2, 3, 4, 5. Let's give our input. This was how much? 9, 3, minus 1, 2, 0. Sorry, 2, 4, 0, 1, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 3 is the window size. Okay, so 3, 4, 4, 4, 5, 6, 7, 4, 4, 5, 6. So this is a very simple approach. Okay, at least this you should have thought of. Everyone good with this approach? How we are finding the maximum in the sliding window? So here I am not doing any sorting. I am not doing anything. All I am doing is according to this diagram. If you see, first I am going these 3 elements. Then I am trying to find the maximum in this 3 element. Then I am trying to find the maximum in these 3 elements. Okay. Okay, so now you have to analyze the time complexity here. So this inner loop will run k times and the outer loop will run n minus k times. So the time complexity will become n minus k into k. So this n minus k is nothing but n only, let's say. So it is n into k. So the time complexity is order of n k. Okay, this is the time complexity of this approach. So is there any better way? So we can also do it with priority queues. So if you let me copy this method. Okay, so in this we can create a priority queue. So first we'll insert 3, then minus 1, so it will be here only. It will be 2, so 2 will be here. So minus 1 and then 2. So whatever is the top of the stack, we will print 3. And then when I'm at 4, I have to remove this element. So when I'm at 4, I will remove this element. When I'm at 0, I will remove this element. So this we have to manually go and remove it. So again, this is nothing but the insertion here is order of k. The removal again will be order of k because I have to just remove this particular thing. So in linked list, in Java specifically, there is a thing called remove value. So basically, we can use that link. We can remove by element. So uh, where is it? Okay, so see this, it removes the elements at specified position of the list. Okay, if not, there is one more thing. Remove object. Yes, it is. Remove the first occurrence of the specified element. So it will remove the actual object. So again, this will be a order of n time complexity. So again, so if you see, it will be order of n into k, 2k, because every time we are doing insertion and removal at every step. So insertion is k, uh, basically insertion is k and removal is k. So this will again nothing but 2k, 2 being constant, we can just ignore it. So it is n into k. So even in priority queue we can use, but that is not helping us. So it is again the same time complexity. In fact, more than the normal approach. So is there any better way? Yes, there is a better way. We can use DQ here. Again, it's a smart way of implementing it. So okay, so what we will do is we will create a DQ. Okay, so in this DQ we will maintain the size of the DQ as k only, we will maintain it as k. Okay, so now our point is we will insert the element, only the required elements. So and then we will remove whatever the unnecessary elements are we have. So if you see in our priority queue, we were inserting 3, -1 and 2. So we can just ignore -1 and 2. Okay, in this sense we have to go, we can remove, but actually we have to, okay, I will explain you. So 3, okay, so the queue is empty, so I will insert 3. Now 1, so this is the part where I'm inserting. This is the part where I'm inserting. Okay. This is the rear, this is the front. Okay, so now -1. So when I try to insert -1, I'll first check whether there is any other element in the list which is greater than -1 or less than -1 or not. In this list, in this queue, if there is any element which is less than -1, I'll just simply remove it because I need a maximum element. So is there anything less than -1? No. So -1 is inserted. So now I'm trying to insert 2. Now you see. So when I try to insert 2, the index of 2 is more than this thing. Okay. So now when I try to insert this 2, first of all, I will check whether there is any element which is less than 2 or not. So there is an element less than 2. Simply, I'll just remove -1. So -1 is gone. And then I'll insert, then again I'll check. So 3 is not less than 2. So I'll just insert 2. So the reason why we removed -1 is because there is no use of -1 here. So in this window, -1 is not used. Even in this window, -1 will not be used. So that's why -1 is completely removed from the queue. Okay. So now the top of the stack, top of the queue is 3. 3 is printed. Now my window shifts to this point. So in this position, when I am at this position, I will have to again insert 4. Okay. So before I insert 4, I will have to maintain my size of the queue as 3, right? So for that case, I will just remove the elements which are not in this range. So as in the previous thing, now the previous solution I've explained, right? In priority queue, you have to remove the elements. So in this case also, we have to remove the elements, but what we will do is instead we will store the indexes. So it becomes very easy for us to the removal strategy. So what is the index 0? What is the index of this thing is 2. Okay. So now what I will do is I will check what is the index of 4. 4 index is about 3. 0, 1, 2. So 3 minus 3 is 0. So all the elements below 0 or less than this should be removed. So this is 0. So I will remove it. So that means before insertion, I will remove all the elements which are not in my window. Okay. So this will actually remove only one element. So uh, we can just say that remove the top of the stack. Again, if it is only less than the index value. Okay. So this 3 is removed. Okay, done. 3 is gone. So now I have to insert 4. Again, when I insert 4, I have to check whether there is any element less than 2 or not, less than 4 or not. So yes, there is element less than 2. So I will remove this 2 also. And now 4. So then I'll just print 4. Then when I try to insert 0, 0 will be inserted because there is no element which is less than 0. But here top of the stack is 4, then 1. So when I try to insert 1, so 0 is less than 1, so 0 is not required. So I'll just remove this thing and then 1. So again the top of the stack is 4. So when I'm at 5, so I will try to insert 5. So 5, before trying to insert 5, first of all, I just skip those steps here. But before inserting 0 and 1 also, we will be checking whether there is any element which is beyond the range. What is the range? Range is k. Okay, so then when I'm inserting 5, I'll just check 4. So 4 is out of range, so I will remove 4. And then 5 will be inserted. So it will be 5, then 6 and 7. This is how we are doing. So in a brief shell, if I have to explain, from this end, I will remove all the write it like this. Remove all the elements which is less than the number we are trying to insert. Okay, and then from here, if you are removing, this is the reason. Remove all the elements which are beyond the window size, window range. Okay, and insertion will happen only from this end. Okay, so before insertion, I will first perform this thing. This is my step 1 and this is my step 2. So now you might think, what is the time complexity of this thing? So if you see in priority queue and this approach, the insertion order was always order of n, so order of k basically, according to the priority. But here the insertion order is always 1. Okay, so we are just inserting at the rear. So before inserting, we are doing this operation. So this and this we are doing. So this will be only one time operations. If you see, that means what? Uh, so it will either insert. So it will insert in the queue and it will remove in the queue. So at the max, we will have k insertion and k removal. So no more than this thing we can do. Correct. So basically, both of them combined will be k. Both of them combined will be k. So they have k elements in the queue, so at the max we can remove only k things. Sorry, not k, n. There are n elements in the array, so we can remove n elements from the queue, very max. Okay, so and we can insert this thing, n elements into the queue. So the time complexity of this approach becomes n plus n. Okay, so this n is for insertion into the queue and this n is for deletion into from the queue. So we will not do k times anything. That logic will not happen. So it will be n time insertion plus n time removal at the very max. So that's where time complexity will be an order of n. Okay. So though we write a loop to remove all the elements k times, but it actually in an overall picture it will be n times only. Okay. So no more than n times that loop will execute. So better I write the logic and explain you. At least you try. Did you understand these approaches? First step, second step, and then third step. Come on, guys, let me know. So this entire efforts we have taken just to reduce the time complexity of order of n into k to order of n. Okay, so I will implement it. So let's say I'm implementing DQ. I'll just implement a DQ quickly. This will be insert at front. Front and rear in front. Okay, so this is done. there will be another known as inserted rare, and this is what we will do basically. If rare is equal to null, okay, so rare is equal to new node, front is equal to new node. And rare dot previous is equal to rare is equal to new node. Okay, let's first see whether we're implementing correctly or not. Insert at front. So we are trying to create a queue something like this. So this is front and this is rear. Okay, so front is equal to null, that means this send is null. So it will be front is equal front of next. So in this case, both of them should point to the new node. Okay, else there is some front value. So front of next is new node and new node of previous is equal to front. Okay, and then front is equal to new node. Okay, inserted rear. So this means this will be the beginning. So rare, so if rare is null, that means I'm just assigning the values. If not, new node of next is rare. Okay, rare dot previous is new node. Okay, and then rare is equal to new node. Fine. Now DQ. So if front, I'll just say delete from rare. Okay, so delete from rare means if rare is null, I'll just return. So I'll not throw any errors just for simplicity purpose. Okay, if not, there is some rare value. So what I have to do is so rare dot next. First of all, I have to store the value rare. Okay, again, I'm implementing in this way. So elements will be added here and removed from here. So rare is equal to rare of next, and then rare node of next is equal to null, and then rare of previous is equal to null. Okay, and then I will just return rare node of data. Delete from rare. So now delete from front. Delete from front. Okay, so front is equal to front of previous. Front of next is equal to this, and front node of previous is equal to null, and then front node of data is we are returning. Okay, so this will, I think, solve our purpose. Let's test it for now. Let's say I'm creating my queue as well. My DQ. DQ is equal to new my DQ. Okay, so I'm commenting out these lines. We will check it later. So for int I is equal to 0, I less than n, I plus plus, q dot insert at rare Okay, so insertion is done. I'll just print it out. Then I will say dq dot delete at rare delete at front. Okay. dq dot insert at front. Okay. Well, let's say how 12 I am inserting. Line number 64. front delete from rare delete from rare. Okay, so okay, so here we should be actually we are doing it in reverse order now, so it should be rare front. Okay, see this 76510 all those things. Okay, this is rare, this is front, this is inserted rare, so everything was added at the rare. So 7 is the last element that is added. Yeah, so now we are doing delete from rare, so 7 is gone if you see. Okay, then we are saying delete from front, so 3 will be gone here. Okay, and then we are inserting at the front, so 12 is added at the end. So if you see, this is nothing but a normal DQ operation that we have created just now. So insert at front, delete at front, delete from rare, and all those basic operations we have created. So now with this DQ, we have to implement or we have to solve the previous problem that we have seen. Okay, first of all, let's pause here and let me ask you, did you guys understand this implementation of DQ? So I just created a DQ here with 4 operations: insert at front, insert at rear, delete from rear, and delete from front. And I'm maintaining it something like this. So this is my rear pointer and this is my front pointer. So front will point to null always. Come on, guys. So this is, we didn't discuss anything yet. So we just implemented a DQ with these 4 methods. And then this is a print method. So in addition to this thing, we will have one more method known as public int peak front. Okay, so it will return the peak value if front is equal to null, return -1. Okay, we can just say return null. I think it will throw an error. If not, just return. So return front dot data. Similarly, we will have peak rare. If rare is equal to null, then just return null. If not, return rare dot data. Yes, and null we cannot pass -1. And there is one more method that we will see is empty. Public boolean is empty. So it is empty only when front is equal to null and rare is equal to null. Only in this case we say it as empty. Okay. So now we will implement this logic. So I am resuming these lines. Okay. So now let's resume this problem. Okay, so this was the base case that we have seen, the order of n into k approach, where every time we do k uh, operations, okay, we find the maximum every time. Okay, but now we are doing something different. So we are saying that we will create dq. Okay, so the very first thing that I will do is first I will insert my k elements. Okay, so that I will do for int I is equal to 0, I less than k, I plus plus, initial q. Okay, so first thing first. So before insertion, I said you right. So there should be some insertion logic here. Let me do it. dq dot insert at rare. Okay, so I'm inserting the index values. If you see, so I'm not inserting the actual value, but I'm inserting index value. Why I'm inserting indexes? With index, I can easily get the access of value, but with value we cannot get the value. We cannot get the reference of index. So that index is useful in also understanding the range of the window, as I said. So every time when I am done with this window, so let's say I'm done with this window and I'm shifting my window to the next state, I have to remove 4. So as a human, I can see it with eyes, but as a computer, I have to give him some index values, right? So that's why I'm using indexes. So before insertion, there should be removal of operation, as I said. So while removing the elements from rare, okay, so while my, so I should write a while loop here because I don't know how many elements I will remove. At max, I can remove 3 elements, but I don't know, right? So I can remove 2 or 1 also. So while my dq is empty, while my dq is not empty, that means head and rear are pointing to some elements, and my error of I is greater than or equal to my dq dot peak rear. Okay, this will give me an index value. This will be the one. Just give me 1 minute, guys. Okay, so just try to understand, guys. So just try to see what I'm typing. Don't just glare at your screens. Just try to understand as well. So while dq is not empty and the last element, that means the queue's last element is less than or equal to. So I'm writing here like this. So if it is less than the element that I'm trying to insert, that means it is a waste element. So I will just remove it. Means dq dot in delete from rare. Okay, so it will remove all the elements which are not required. So okay, this is done. And then for the next steps, what I will do for int I is equal to k, I less than or less than arr dot length I plus plus. This is not required. Okay. So now the first thing that I should do is print the top of the queue. So for that I will do system dot out dot print dq dot peak front. Okay, so this will give me the top of the queue. I'm saying top means front of the queue. So again, this is an index, so I have to print the value. So that's why I ARR of this thing. Okay. So this way it will print the value. Okay. So now even now I have to insert something. So I have to insert this thing. But as you see, my first step is remove all the elements from which are beyond the range, and then remove all the elements which are less. So remove all the elements which are less. This is the one. Removing elements from where which are less. Okay. So before this step, I have to remove all the elements from the front. So again, here there will be a while loop. Basically, it will be only one removal, but still we can write a while loop as well. Removing elements from front which are out of range. Okay. So again, while dq is not empty. Okay. While dq is not empty and q. So this is q dot peak front because I am removing from front. Q dot peak front is less than or equal to my I minus k value. Okay. So this you have seen, right? So if I value is 4, let's take this as an array. So if I am at this position, okay. So if I am at this index, so 4 and the value is 3. 4 minus 3 is 1. So from one index, everything I have to remove. So that's why I minus k. 4 minus k is 4 minus 3 is 1. So less than or equal to I minus k, and that means I have to remove something. So in this case, I'll just say dq dot delete from front. Okay, so it will remove and it will then insert, and it will just continue, and every time it will execute. So this will run for how many times? N minus k times it will run, and the last value is still not printed. So for the last value we will just insert it. So if you see, printing is happening at the beginning of the loop. For the last value we will just insert and the printing will not happen. So for that I'll just paste this line after for loop. So this will print the last maximum value as well. Okay, so let's run this logic now. Delete from rare. What is the problem? Line number 135. Okay, it's not Q, it's DQ. Exception in main thread, null pointer exception. So after 3, there is some problem. So let's see. Delete from rare. This method is having problem. Delete from rare. Okay, so okay, so if there is only one element that we are removing, so in that case we have to be very careful. So this is a problem here. Okay, so here we have to do a checks, right? So if there is only one element and then we are trying to delete it, so we have to do something. So here, if my rare is equal to null, then fine. If my rare dot next is equal to front, okay, that means there is only one element. Okay, in this case, what I have to do is first of all store the value. Int data is equal to my rare of next is equal to null. Basically, there is only one element. Okay, then rare is equal to null, and then front is equal to null. Okay, So this is the case that we. Okay, else we can do the same thing. So this should work now. The same will happen in delete from rear, right? Delete from front as well. If my front of previous is null, then this is nothing but front of data. Okay. This is rear, this is front. Okay, let's just see 3 4 4 5 6 7 and 3 4 4 4 5 6 7. Yeah, so it's working fine. So if you now understand, though it might look like this loop is running how many times, n times, so this loop will only run how much times it will run, the number of times my elements are there in the queue. And the my queue, once I insert and once I remove, I will not do anything. That means the my queue can only have n elements, and insertion and deletion can only be n. So these loops will only run n times. Okay, and for n time for insertion, n time for removal, very worst case. So the overall time complexity will be n plus n. So that's where it becomes the order of n time complexity. N plus n is to 1, which is nothing but n. So did everyone follow the solution? So from n into k, so from n into k, we made our solution to order of n. Are you guys listening to the session? Okay, let me. So what did I write just now? Let's see how many answers I get. Only 3 members. So just now I've written something in Notepad. I'm just trying to see how many people are paying the attention to the session. So out of 142, I'm damn sure that 142 are not paying attention. I'm just checking how many are doing that. Come on, guys. You're just wasting your time waking up so early in the morning, and if you're just waking for the sake of attendance, I don't know how you guys are joining. But if it is just for attendance, then you're simply wasting your valuable time. Better you sleep off than attending the session. So, any questions in this approach, or any confusion in this approach? Let me give you this entire file. Can you explain the peak part? Okay. So this peak is nothing but getting the top of the queue. So if you see, So if I have some queue like this, where is it? Okay, so let's say I have a queue like this, 3 minus 1 and 2. I just want to see the value. I don't want to remove it. So for that purpose, I am just peeking. So peeking is nothing but seeing the value. So if you just see, peak.read will just return the data. It will not do anything. Okay. Even here, it will just return the data. It will not do anything. Similarly, we are here just checking the value. So for checking, we don't want to remove it, right? So we are checking the peak rear value and then peak front, something like that. Okay. If you notice here, we are just checking whether it is in range or not. So we are inserting indexes into a queue. That's one thing that we know. So that we are checking that what is the front index, if it is in the range or not. If it is not in the range, then just remove it. And here, if the value is less, then we are removing. So here we are checking the index. Here we are checking the value. So I'm sending you this file, this entire file I've sent you. It is having logic of Q, it is having the logic of DQ. So both the logics it has. Okay, let's move on to the next question. It took quite a big time. So the next question is sum of maximum and minimum elements in all subarray of size k. And now I want answers from you. So now you know how to find the maximum in sliding window. Now the next question is again the extension of it. So now you have to find the sum of all the maximum and minimum. Let's say this is the array. So 3 minus 1, 2, 4, 0, 1, 5, 6, 7. Okay, if this is the thing. So what are the windows? So let's say window size is 3. So what is the first window? 3 minus 1, 2. Then minus 1, 2, 4. Then 2, 4, 0. Then 4, 0, 1. Then 0, 1, 5. 1, 5, 6. 5, 6, 7. These are the window size. So I want to find the minimum and maximum of each window, and then I have to calculate the sum. So minimum is what? Minus 1, maximum is 3, minus 1, maximum is 4, 0, 4, 0, 4, 0, 5, 1, 6, 5, 7. So now I have to calculate the sum. So sum is nothing but 2. Here it is nothing but 3, it is 4, 4, 5, 7, and then 12. So this should be the output. I want to print this. Okay, this is the question. Find the minimum and maximum of all subarrays of size k. Okay, subarrays of size k is nothing but sliding window of size k. And then I have to find the sum of them. Okay, is the question clear? Okay, so now you have to solve this. How will you do it? Yeah, so brute force will be the same approach, but it will be, we have to find min and max, so we can write just another for loop. So it will be order of n times 2, order of n into 2k, because we are running the k loop 2 times, one for the minimum, one for the maximum. So it will be order of n into k, okay, the same thing. But now we want to avoid that thing. So from n into k, I want to just have an approach or time complexity of order of n. How will you do it? So we have just seen how we can do this thing. So we have just wrote the logic for this thing maximum. So all we have to do is find the minimum as in the same approach. Once I have minimum, once I have maximum, I can simply find the sum, right? So we will use the same approach. So again, we can maintain two queues and we can do this thing. So I'm just copying this up method. I'm just saying it's sum. So sliding window, yeah. So this is my max DQ. This will maintain the track of my maximum elements. Similarly, I can maintain a DQ for tracking the minimum elements. Okay, so this is my max. Max DQ. This is my max DQ. Okay, so done. So this is the entire logic is written for the max DQ. So now same thing I have to do for min DQ. So I can just copy paste this thing twice and I can do it. So time complexity will never change. For the finding max it is n, for finding minimum it is n. So it is at the end it is n plus n only. Okay, so instead I will just write it here. So this entire thing I'll just copy and I'll paste it. Min DQ. Okay, so this thing, if array is less than this thing, min DQ and then min DQ. Okay, so this will initialize both the queues, min and max. And now similarly, I have to do the same thing. Min DQ, min DQ. So range is fine, but here it should be min DQ, min DQ less than min DQ. So max DQ dot insert and then min DQ dot insert. Min DQ dot insert. Okay, so this thing will initialize both my queues in one go. Okay, so previously I was just printing the value, but now I have to print the sum. So I can just simply write like this. It is min DQ. So this will print the value, print the sum. So I'm doing an arithmetic operation here, plus. Okay. Yeah, there is no compile time errors. Now let's see maximum sliding window. ln, let's do ln. Sum of maximum in sliding window. Okay, so let's see 2, 3, 2, 3, 4, 4, 4, 4, 5, 7, 12, 5, 7, 12. Okay, so it's working as expected. So eventually here also time complexity, this will run this loop. So these three will combinedly run for n times, no more than n times. And again, this three will run n times, so no more than n times. So n plus n, it will be order of 2n. So it will, the time complexity is still n, okay? So I'm just giving you this logic again. Just go through it if anyone is having any confusion. It is just a simple DQ logic, and you're making use of DQ to solve a problem. Just check whether you have got the file or not. I've sent you the file. Okay. So with this, I think we are above. We are on time. We don't have much time to discuss any further questions. So let's go with the schedule. So we have seen queues, we have seen DQ, we have seen few problem statement, and this is an important problem statement, guys. So these are a few standard questions. So like in linked list, you should know reversal of linked list. In stack, you should know stack operations and all those stuff, right? So basic standard question of stacks will be like finding whether a string is balanced or not. So again, this is a balance standard question of queues. You all should know this sliding window problem because it is important and frequently asked questions as well. So if you are confused, just go through this approach, guys. So just try to understand what is written here. So this is a normal queue logic. So but this is a normal DQ logic. So there are 4 operations: inserted front, inserted rear, delete from front, and delete from rear. So if anywhere, if there is any mistake, you try to clear it out. I've written it assuming things. I think it should work for all the cases, but still, if I have missed any corner cases, just think of it and fix it. Okay. Okay. So any questions or any doubts? So how are the sessions going? Are you guys feeling comfortable, or is it too slow, or is it too fast? Do you need any change in how we are taking these sessions? So, okay, only 6 to 7 members have messaged saying good. Okay, rest I'm assuming that they are either asleep or they are busy with their own work. Okay, anyways, just try practicing problems, guys. Practicing is the only key. No matter how much I speak here or how much I explain stuff here, you should at the end you should be the one who should practice the problem. So just go through some practice problems like from lead code or hacker rank or anything like that. So just practice problems and make yourself comfortable with coding first of all. So these approaches, no one can think of this approach in a time frame of 10 minutes or 15 minutes. No, this I am explaining here so that you can think, or you can just broaden your mind up, saying that okay, this is also possible. We can use this data structure here. But in order for you to think of this logic, you need practice. So you can only assume, or you can only create your own solutions once you have solved few solutions, and you will try to you'll understand that there is a pattern in this problem and we should use this data structure. So just keep practicing till that point, and once you reach that point, problem solving will be very easy for you. Okay, I think we are good with the time, guys. So thanks for joining. We will continue in the next session. Next session, we will start nonlinear data structures. So we will start with the binary tree. We will see what is a binary tree, how is it different from linear data structures, time complexity wise, and all those stuff. Okay. So take care, guys, and keep practicing.